Hi guys, this is Mr. Urrego, and today we're going to find the inverse of a function. We're going to prove when two functions are inverse to each other. By the way, this symbol is my inverse, f negative 1 of x. That means the inverse of a function of x. Let's go. My first question, find the inverse of f. My function is f of x equals 7x minus 5. There's a couple steps. My first step is replace f of x by y. Second step, what's y turns into x. What's x turns into y. And from here, I gotta solve for y. Cancel the 5 on both sides, so I'm going to have x plus 5 equals 7y divided by 7, and now once I cancel and when I leave the y by itself, I want to replace this y by the symbol of the inverse function. So my inverse function is x plus 5 over 7. Okay? Now, let's do something. We need to double check if these two functions are inverse to each other. So, proving that two functions are inverse functions. So, if I have my function and my inverse, obviously, if I did the process right, this is going to work out. So, if I do composite functions between my function and the inverse, I should get x. If I get x, that means this function and the inverse that I found are inverse to each other. If I don't get x, then they're not inverse to each other. So, let's start. F of f inverse of x. So I'm going to rewrite this as the composition of function. Why? Because I want to replace the inside function. By the way, check this video, composition of functions, composite functions. I replace the inside first, which is my inverse. My inverse is x plus 5 over 7. And then I replace the outside function, which is f. My f is 7x minus 5. 7x minus 5. Whatever I see the x here, I put a parenthesis. And then I bring down whatever I have in the previous parenthesis, which is x plus 5 over 7. And now I solve algebraically. Whatever I have to do, you see that this 7 is multiplied in this parenthesis, so technically this 7 and this 7 can cancel out. And I'll have x plus 5 left, minus 5, and then 5 minus 5, and my final answer is x, which is what I want. Therefore, I'm proving that those two are inverse to each other. Another way that we need to double check is f inverse of my function. So the order changes. F inverse of my f function. So here, my inside function is f of x. So I keep that inverse on the outside and I replace my f of x, which is 7x minus 5. 7x minus 5. And now my outside function is the inverse. And the inverse is x plus 5 over 7. So it's x plus 5 over 7. In this parenthesis will go whatever I have in my previous parenthesis, which is 7x minus 5. From here, solve algebraically, which means solve whatever you see. No need for this parenthesis, so this negative 5 plus 5 will cancel out, and I have left 7x over 7. 7's cancel, my final answer is x. If when I do the composite functions of between those two and then my value is x, then that's proven that this and this are inverse to each other. Okay? Let's practice a little bit more. Let's practice finding the inverse function. I have a different function. Again, same steps. My first step is replace f of x by y. Once I have that, I'm going to interchange what's y turns into x and what's x turns into y. Make sure you keep the parentheses, the exponent, whatever they have left. And now at this point, I solve for y. Minus 1, and that's going to give me x minus 1 equals y cubed. Now, keep in mind that I have to get rid of this cube. Therefore, I have to do cube root of on both sides of the function. This cube root will cancel the cube, and then I have y. In the other side I have cube root of x minus 1. And that will be my inverse function. Therefore, this y, I turn it into f negative 1 of x, which is equal to cube root of x minus 1. And that's my inverse function. What about if I have a radical? So, same idea. What's f of x turns into y minus 1. Then the y turns into x, the x turns into y, and the minus 1 is on the outside. At this point, I got to solve for y. Plus 1 plus 1, so I have x plus 1 equals square root of y. How can I get rid of this square root? You raise to the second power. Remember, you have a tiny 2 here in the radical, so you raise it to the same exponent in this case. Whatever you do on one side, I do the other side. Therefore, I have x plus 1 to the second power in the other side. The radical goes with the exponent, and I have y in the other side. Now, you can solve this, x plus 1 to the second power, which is going to be x plus 1 times x plus 1, and that's going to give me x squared plus x is 2x, 1 times 1 is 1. So this turns into x squared plus 2x plus 1. Instead of the y, I write my inverse function notation, and this is my answer. Okay, let's practice another one. This is a bit more complicated. A rational function, but the steps are the same. F of x, instead of x, I write y. 2x plus 1 over x minus 3. Interchange. The y turns into x, and whatever I see an x turns into y. X turns into y minus 3. The idea is to leave the y by itself, but now I have two y's. So the process here is the following. The idea is to get rid of this denominator. So how can I cancel something that is divided? That's right, I multiply on both sides. This y minus 3 will cancel this y minus 3, and I'll have x times y minus 3. Distribute x times y is going to give me xy. Negative 3 times x is negative 3x equals 2y plus 1. But I see that I have two y's, and the idea is to have only one. So here's the trick. I bring this y to the left, and I bring the x to the other side. So let's get rid of this 3x. Plus 3x plus 3x. So I have xy cancels equals 2y plus 3x plus 1. This y to the other side. Minus 2y minus 2y. And here I have xy minus 2y. 2y minus 2y cancels equals 3x plus 1. Here comes the trick. I see that I have y here, so we take a common factor. Let's bring this over here. xy minus 2y, 3x plus 1. I have y here and y there. I take y as a common factor. xy divided by y gives me x. 2y divided by y gives me 2. Equals 3x plus 1. If you notice, by doing this little trick, now I only have one y. So the whole idea about this is to make sure that I bring the y's in one side and the same side, and at that point I do common factor. From here, simple. Cancel the x minus 2? Yes. Divide. X minus 2, x minus 2. The y is by itself. 3x plus 1 over x minus 2. The y is by itself. Inverse function notation. Rewrite everything the same. And this is my final answer. Don't forget the restriction. In this case, x cannot be equal to 2. X cannot be equal to 2. That's it for today. Take care, guys. Subscribe, like the video, and comment. Questions, put it in the comment section. Thanks a lot for watching. Bye-bye.